All right, so now we have a quadratic. F of x is equal to negative 3x squared minus 6x plus 24. We're going to find the vertex of the graph of f, and then we're going to find the rest of it. But first, with the vertex, we're going to use that vertex formula. So we start off with h equals negative b over 2a. So identifying a, b, and c, a is equal to negative 3, b is equal to negative 6, and c is equal to 24. So h, we can find, is negative b over 2a. So negative b is negative 6 right there over 2 times negative 3. And so we have that negative, so that actually ends up being a positive. So a 6 over then negative 6, which means we get negative 1. So that is, now that's the h value, which is really the x. Remember, our ordered pair for the vertex is hk. To find k, we then plug in h into the function. So that means we're going to plug in negative 1 into the function. So it's negative 3 times negative 1 squared minus 6 times negative 1 plus 24. Okay, so we have negative 3 plus 6, then plus 24, so that would be 27. So that means that the ordered pair is negative 1, 27. To find the y-intercept, we need to let x equal 0. So for the function, f of 0 is equal to negative 3 times 0 squared minus 6 times 0 plus 24. So it ends up just being the constant term. So our ordered pair is 0, 24. Next is find the x-intercepts of the graph. Okay, the x-intercepts is when y is equal to 0, or in this case, f of x is equal to 0. So if f of x is equal to 0, that means the whole thing here, this is equal to 0. So we're going to have negative 3x squared minus 6x plus 24 is equal to 0. Okay, notice that they're all divisible by 3. I'm going to do specifically negative 3. So I'm going to divide every one of them by negative 3. So that gets me x squared, then plus 2x, then minus 8. Okay, and so two numbers that add to a positive 2 and multiply to a negative 8. So this is then x minus or plus 4, and then x minus 2. So that means x plus 4 is equal to 0, which means x is equal to negative 4. And then x minus 2 is equal to 0, so x is equal to 2. And so we have two x-intercepts from that, negative 4, 0, and 2, 0. Now it says find the equation of the axis of symmetry. Remember, the axis of symmetry is always x equals h. It's an equation, so we have the x equals. So in this case, h is equal to negative 1. So x equals negative 1. Sketch and label everything from parts A through D. So we're going to go ahead and make that. Sketch it all. So okay. And so, like I said, don't worry about, so we're going to have this axis of symmetry right through, negative 1. Don't worry about labeling tick marks for the y-axis. Just do it for the x. So x equals -1. So that's the axis of symmetry that we needed. And then the vertex. So we're going to just go ahead, put it on the axis of symmetry. And then once we label it, -127 is true. 0, 24, say somewhere about right there. It goes to the points 2, 0, and -4, 0. And there's also the extra spot here where we see is that we have the extra point we can get is this, that this is a distance of 1 away from the axis of symmetry. So we have another same y value at a distance of 1 away. Okay. So we have plenty of points to connect. So it comes up and it goes through and it goes through there. Okay. And so we have here 0, 24, here 2, 0, -4, 0, and even this extra point here, which is -2, 24. Okay, so even though we didn't have to put that there, it's good to see it. All right, and that's all the things that we saw from parts A through D. Now, let's go ahead and see the rest of it. It's going to say on what interval is f increasing. So notice as we read from left to right, the graph increases. So it's going up for x values, starting from -infinity up to the axis of symmetry, where the vertex is. So remember, when we say where is it increasing, we're talking about the x values. So that's a -infinity up to -1. Okay. On what intervals is f decreasing? Again, where is it going down from left to right? So we can see we have a downward from the vertex onward. So we have then from -1, and then we're going to continue all the way for x values to positive infinity. All right, f has a local, so looking at it, it opens downward. So it has a high point, the maximum, a local maximum. Value of, so the maximum value is the value of the function f of x. That is the y value, 27. Okay. At x equals -1. The domain of the function, so it's from -infinity off to positive infinity. So that's the x values. The range, so looking at it again, we're going to see that it has its highest point at 27, and it covers all values below it. So really, it's all values up to here. So we're going to go from -infinity up to 27. And we include that 27 because it is the vertex. It's a point on there. And that is the end of that example.